Let's say if you wanted to create a minimum variance portfolio and a maximum return portfolio based on the four stocks: Apple, Chesapeake Energy, Netflix, and Walmart. And then the next step, as the next step, you wanted to create an efficient portfolio starting from minimum variance portfolio to maximum return portfolio. Then you would first want to type in the formulas here, and then starting from there you would want to run a solver so that you can find the minimum variance portfolio and also maximum return portfolio. So let's just assign random portfolio weights here. For example, 100% in Apple and 0% in everything else. These are just random numbers to start with, so you can just copy to maximum return portfolio. And here the sum of the weights of the four stocks would be 100%, right? And now it's the time to compute the expected return. And the expected return should be, you can use the matrix multiplication function here as well, but to make things simpler, I will just go with sum product since we are using only two columns here. So start with sum product, and you want to start with the expected return column here, but then this is in a row, so it might be better to put it as transpose the row here. Then it will be just change it back to a column form in comma. And the next thing would be putting the weight column, right? And close the parenthesis. But one more thing I want you to note here is because we are going to lock up the row here, the expected returns. So press F4 just once so that the whole row is locked. And then at the end, do not just press enter, but press Control Shift Enter, right? And it will give you the return amount of 1.59%. And once you're done, you can just copy to the end of the range. Next thing would be standard deviation. So the formula for standard deviation is quite complicated and challenging, so I'm not asking you to remember it, but still I'm just going to type it just for this cell here. So the formula here would be, the function is matrix multiplication, and let's just try to transpose the column here because you want to put it as a row for the starter. And then the next array would be your variance and covariance matrix. And then you just close it. Now what has been done is just multiplication of your weights and the variance and covariance. And you want to do another matrix multiplication with you know the multiplication you just have done with your weight column one more time, and there you go. This would be the variance of the portfolio. But then you are looking for standard deviation, right? So it's probably better that you put square root outside of this multiplication form, and then this will be the portfolio standard deviation. And one more time, you are going to copy and paste to the end of the range. So you put F4 for the variance and covariance matrix that you're using in between. And then since you're done, you just press Control Shift Enter. And there you go. This should be your standard deviation amount. Why don't you copy it to the end of the range? Now you're ready to solve for the minimum variance portfolio. So your goal here would be to find a portfolio or the combination of weights that would give you the minimum standard deviation. So This is an optimization process. So you go to data and you should have solver installed on your Excel. So go to solver. So if you wanted to delete everything or just erase everything that was just kept inside, why don't you reset all and your solver will start from scratch. And then here, your objective would be having your standard deviation minimized by changing all your weights. And the constraint here would be having sum of weights being equal to 1. Oh, say OK. And that's it. You have determined all your parameters. And you're making unconstrained variables non-negative. So what this means is you are not allowing any of the weights to be negative, meaning you are not allowing any shorting in this process. And this is a nonlinear function. So you just leave it this way and then go to solve, say OK. And say OK to keep solver solution. And there you go. So what this means is if you invest 20.89% in Apple and 68.82% in Walmart and around 5% in both Netflix and Chesapeake, your portfolio would give you the least risk. And what about maximum return portfolio? You will use the solver function again because this is another optimization process, but your objective and the constraint would be different. So let's go to solver and let me try to explain it. All right. So again, your solver parameters will just include all the information from the previous process. But if you want to reset it, just click reset, and you will start from scratch. And your objective here would be again setting your portfolio standard deviation to the minimum level. Because you don't, obviously you want to have the minimum, the lowest level of risk as possible, even, with a given amount of return by changing variable, which is the weights. And your constraint here would be having the sum of weights equal to 1. Up to here, everything is exactly the same as minimum variance portfolio, but you should have um, one more constraint, which is having your portfolio's expected return greater than or equal to the maximum return amount among the four stocks. So for example, among your stocks, Netflix is providing you with the highest amount of expected return. So you want your maximum return portfolio to generate as much return as the Netflix return. Okay, that would be your constraint. Say OK. And so here, so you should be able to interpret what this parameter or all this process means. So you are setting your portfolio standard deviation to be minimized by changing the weights, but then you still want to meet these constraints, which is having the sum of the weights being equal to 1, and the other one, which is more important, would be having your expected return at least as much as the return from the stock that gives the highest expected return. Okay, and given that you're still assuming that there is no shorting allowed, and then go to solve and say OK. And what do you notice here? So given that you're not allowed any shorting in this process, the maximum return portfolio would be exactly the same as investing the total amount of your money in Netflix, which should be the one with the highest expected return amount, right? If shorting was allowed, things would be a little different, but in case you're not allowed any shorting, then your best option in terms of maximizing your return would be just investing everything in the stock with the highest return. All right, so you now have all your ingredients, and what you will do right now is to change the portfolios in between. So what what does this number mean? The number means that you're investing 90% in minimum variance portfolio and the rest, which is 10% in maximum return portfolio. This would be 80% in minimum variance portfolio and 20% in maximum return portfolio, and so on. So how would you do that? This would be the same thing as 90% times Apple's weight plus 1 minus 90%, which is 10%, times the percentage in maximum portfolio, right? This would be perfectly correct, but then if you wanted to copy and paste to the end of the cells, end of the range, then you would probably want to use the F4 key so that you can lock the cells. So here, this cell you want to be locked on the row but not on the column. So you will press F4 twice so that your dollar sign appears in front of the row number but not for the column number. So that would be the same thing for here as well. So you press F4 twice so that row is locked but not the column. But it's different for the weight weight cell. So here what you would want to do is you want to fix the column but not the row. So you're going to press F4 3 times so that your column is fixed but not the row number. You want the row to be rolled over, right? Same thing here. So you're going to press F4 3 times so that your column is locked. So you're going to use the same column here but not the row, right? And then you press OK. And you see that it gives you a very weird number. Why don't you go to number and just say your decimal places would be just 2 would be just fixed to 2. And then you just copy and paste to the end of the range, and there you go, right? All right, so given this, if you want to check out your efficient frontier, you will go to chart 2 and you will be able to find that your efficient frontier that you created with the 4 stocks, Apple, Walmart, Chesapeake, Netflix, it would give you an efficient frontier that would look like this. So if you were creating a set of portfolios based on these 4 stocks, this would be the point that's going to give you the least amount of standard deviation or risk, right? And what you can notice here is that the level of risk is much smaller than any of the standard deviation that you can find with individual stocks. And here, this is the point where you will be able to find the highest amount of return among these 4 stocks or the portfolio that you created with these 4 stocks, and this will be equivalent to just investing in Netflix.